All right. Hello, everybody. Welcome to Vector Space Talks. Today, I'm here super excited. We have a very special guest, Reece Griffiths, here to talk with us about metadata and how to optimize it and how to scale it. And I'm here also with Terry. Hey, Terry, how are you?
Hey, what's going on, Sabrina?
Awesome. And yeah, Reese has lots of insights and is going to walk us through a presentation and a demo, teaching us how to use Deasy Labs and teaching us how to scale our metadata. And this is super interesting, Reese, because we see a lot of people talking about embedding models, right? And how they're important and how you need to choose the right one and how they matter, maybe the distance metric and stuff like that. But few people really talk about the big importance that metadata plays when you're doing retrieval, right? Can you talk a bit more about that? And hey, thank you for being here.
Yeah, thanks for having me, guys. It's really great to be here and looking forward to the discussion. Yeah, exactly. So I think a lot of that also comes to where we are in the sort of Gen AI adoption cycle, where lots of people are at the sort of POC phase, and only once they go from that proof of concept into thinking about more production settings do a lot of the issues around managing large volumes of data come into play. And the way we think about it is both kind of really two steps. One is like, how do I set up the right knowledge base for a given use case? And again, in the POC world, I think what we see is the data sets are already quite nicely curated. People know what data they want to work on, and it makes sense. But the reality of, especially in the enterprise world, when you go to then scale to more and more use cases, that process of figuring out what data do I even have, what is relevant, what is up to date, what isn't sensitive, becomes a very complex problem. The second piece is, and I think lots of companies have realized this over the last year, is bridging that kind of 75% accuracy, let's say in a RAG or retrieval system, and getting to the kind of 95% range is hard. And in many cases, that sort of 80% accuracy might be as good as zero. And this is where we also see like that metadata to either contextualize the data, to improve kind of the filtering, the routing, maybe even embedding the metadata to sort of fine tune in some ways your embedding space, can really help you, tailor that last mile. And so for us, metadata is, one of the key unlocks to both that segmentation and file organization to like set up the right knowledge base, and then to basically enrich that knowledge base to hit that last mile of either sort of accuracy or even speed.
I love it. And I know you have a presentation for us, so I'll let you take it away and do also a demo. And I 100% agree. And there's many different ways in which metadata can be used, right? And I think you're going to walk us through all of that.
Exactly. Yeah. So I'm going to, let me share screen. Hopefully this works. Always a risk. The screen sharing. So let me know.
Yep, we can see your screen.
Perfect. And hopefully you see sort of presentation mode, right?
Yes.
Yeah.
Awesome. So we will spend most of the time looking at the actual product and talking through the actual software and how this works. But yeah, I think we covered a bit of that framing up front. So the way to think about Deasy Labs, and maybe just for background, so we're a data company based in New York, previously part of Y Combinator. And our entire focus is around metadata. And one topic that I think is always important to cover up front is, what does metadata actually mean? Historically, to some people, this is like, file type and, version and last edited date. In the world of Gen AI and using LLMs, metadata can obviously mean basically anything you possibly want to extract from the data. This can be categorical metadata, entities, but also highly descriptive metadata. So we'll talk about, we already touched on a little bit, why does metadata matter? We'll then go through kind of a product demo, which will be anchored in this idea of, I have a bunch of data in my Qdrant VexDB. I want to build a specific RAG use case on a subset of that data, and I want to enrich that with very specific metadata. How do I go about that process? So maybe at a very high level, I think I just sort of alluded to this, but why does metadata matter? Going from a very large sort of real corpus of unstructured data, especially in larger companies, to an end use case that is accurate enough and continually maintained with new data that is coming in over time is full of a lot of problems along that way. So understanding what data exists in the first place. Is that data relevant for my use case? Is it up to date? Is it sensitive? Is it redundant? How do I then create good metadata taxonomies without, and this is what we often see, without an over-reliance on sort of domain experts and business teams? And this is one of the core pieces, like metadata can be, can be very generic, kind of like summary and entities, but where a lot of the value is when you get to sort of highly specific metadata. And that kind of domain specific metadata, I think for us is with LLMs as a way to kind of derive that without a reliance on domain experts. And then how do we use that metadata either for, as I mentioned, for routing, for improving our embeddings, or for some kind of agentic strategy? And then finally, how do we use this metadata as kind of an anchor point to make sure that the data in my vector database is continually the right data as new data is produced over time? Can I just get a confirmation you can still hear me? Because I had a pop-up on my laptop saying that AirPods have been connected, and that's never good.
We can.
We can hear you.
Okay, great. So we think about segmentation and enrichment type metadata. So how do we organize our data? How do we basically automate cataloging at scale? And then once we have our knowledge base, how do we come up with very specific metadata that is tailored towards the specific use case you're working on? And it could be that, depending on, let's say, a RAG use case, depending on the set of questions that you're asking, different metadata is going to have a different impact in terms of allowing you to quickly segregate that data when a given query is being asked. So segmentation metadata is around ensuring you have the right data in your knowledge base, and enrichment is about representing your data in the right way to give, let's say, an LLM, more context to allow it to retrieve the right node. And on this latter part, we've done quite a lot of work on looking at different ways metadata can be used to enhance specifically retrieval hit rate. And we can talk about some of those as we go through. One other distinction here is sometimes we think about segmentation type metadata might be more helpful for humans who are trying to catalog and understand the data, whereas enrichment can be kind of very detailed and not necessarily, or very descriptive and not necessarily helpful for a human. But if you're embedding that, let's say, then it can be very powerful from a retrieval standpoint for the LLM. And maybe just to show you,
sorry, Reece, I wonder also if we can embed those into sparse vectors and use this for hybrid search. I feel like this would be even maybe an optimized kind of keyword search in a way, right?
Exactly. Yeah, exactly. That's a great point. So we released a white paper last year on exactly that. So this is actually a good segue. So this was a chunk of data from a research paper. We then kind of auto-generated a bunch of metadata about this chunk. Now, on the left, you see, on the right, sorry, some of these are generic tags like summary and entities and so on. We also sort of, based on some of the Anthropic research around contextual retrieval, we also think about sort of contextual metadata. But then there's a lot of very specific tags that were tailored towards this particular data domain. And what we did in this case, we actually embedded all of this metadata into one dense and one sparse vector. And then we use those actually as metadata embeddings. And actually in the white paper, we actually didn't use the original chunk at all. We actually just used the metadata embeddings for the hybrid search. So we did cosine similarity between incoming queries and the metadata embeddings only. The kind of most generic approach here, though, that we see always adds some value is if you, let's say, concatenate the metadata with the chunk, re-embed, and then you can you start to sort of tailor your embedding space towards your specific RAG use case. And I think, we have a slide just showing kind of, a very high level what this can look like. So metadata can both improve the accuracy, but also retain that accuracy over time as data volumes increase. And, we talked about embeddings there, but, routing based on metadata filtering, some of those techniques to basically just reduce my knowledge space, the size of my knowledge space as quickly as possible is where a lot of the value can be. So last slide, and then I promise we'll go into the product. So when we think about, what is required from a metadata perspective to actually really have an impact on a search system, there's many dimensions, but for us, metadata should be customized to the use case. You should be able to validate metadata accuracy and refine it, so tailoring it to a particular data domain. Metadata should be scalable in that, we're talking here often about tagging potentially millions of documents, but not just at the file level, but also at the chunk level. So extracting very granular metadata at scale. Metadata should describe not only text, but if I have charts and tables and images within a document, let's say we're tagging for sensitive data, and in my PDF there is a screenshot, of a passport in there. It's critical that any metadata that says, does this contain sensitive information, is going to capture content in images as well. Metadata should be hierarchical. So I just mentioned this. We think a lot about how do you build the right relationship from chunks, so it could be at page level, to document level metadata. And depending on the types of tags, the way that you would synthesize a date tag is very different to how you'd synthesize like a descriptive tag or entities and so on. Metadata should be maintained over time. So, as categories are being updated, new data is coming in, taxonomies should be dynamically updated. Metadata should be standardized so I can actually use it effectively for filtering. And a big part of our focus is metadata ideally should be auto-suggested. So we shouldn't have to rely on, business teams to always come in and define the taxonomies and the relevant tags. Data and data science teams should be able to do that in an automated way.
So you mentioned earlier the two different metadata categorizations that you had, which were the segmentation and the enrichment. And you kind of mentioned the juxtaposition there between one of those being more data that's built for humans, and then one is more data built for machines. And you kind of touched on that at the end when you mentioned you don't want to have a system that needs that domain expertise simply to build out your ontology. So can you talk a bit in terms of enrichment and segmentation, can you talk about how you approach looking at a data set and deciding which one is more important? Are they equally valued? Are they both necessary?
So the first thing I would say is we don't, within the product, we don't make any explicit distinction between those two types of metadata. Often the way we more think about it is actually kind of the granularity of the metadata. And so we'll go into this in the product, but we build kind of these hierarchical tagging structures where the first level, the idea is that maybe, we want to first split out by file type or date and so on, and then theme. And then within theme, we want to split that out into sub-theme. And then we start going deeper and deeper. And I think maybe the way to sort of map this to the human versus LLM is that potentially the high level metadata for sort of cataloging use cases is very helpful for understanding at a high level what data does exist. But as you go increasingly granular and you get to kind of more and more detailed tags, they may be potentially less relevant for some sort of cataloging use cases, but potentially very valuable from a use case perspective. And by use case, what I mean is, let's say the use case is actually you're trying to build some kind of predictive model on some unstructured data. The metadata we're generating there is kind of like a very specific feature set for that corpus of unstructured data. And again, so from a cataloging perspective, maybe not as so helpful, but from the model perspective, auto-suggesting very specific tags to that corpus could be very valuable. So that's kind of how we think about that.
Yeah, I was just thinking about kind of animal naming, or I should say animal categorization in the scientific world. How first we have mammals, then it gets even more, and then we get all the way down to Homo sapien, where depending on what your use case is, you might not need to know that it's a arachnid major, right? You just need to know it's a spider.
Exactly. And this is one of our core thesis of the company is it's so use case dependent. The right metadata, how you represent the data, what is the taxonomy? It depends on what you're trying to do with it. People often ask us, do we have out the box schemas, out the box metadata? And we often say that we can, but it's always much better to tailor it towards your use case and your data domain. So our approach is actually deriving the metadata from a corpus of data. So, and maybe this is a good segue into the platform, which hopefully you guys can see. Let me know if not.
Yeah, we can see the platform. I love that analogy. It's almost like going into a restaurant and then saying, surprise me. And then they serve you the food you hate the most. And you're like, hey, I don't like this restaurant.
Exactly. I mean, it's interesting for two reasons. One is we've had some domain experts in the legal space, for example, who they had a corpus of data and they thought they knew the tags they wanted. And we said, like, just run the auto suggest and see kind of what other tags are generated. And basically it showed them a new way of looking at their data. So they still retained 80% of the tags that they already, the metadata they wanted, but they saw some additional metadata attributes and parts of a taxonomy that they'd never really thought about. That using a model to actually, because the way we do this, we actually analyze document by document first, and then come up with the schema. And that is, that can also add a lot of insight even for domain experts. The second thing I wanted to say, though, is, in some very specific domains, of course, like you might not be able to get to exactly the same taxonomy that an oncology or an R&D expert in the pharma space might. But what this does is massively accelerate the process, and it allows the data or data science teams to quickly derive, let's say, a first pass that can then be taken to a business team, and then that conversation can be accelerated much quicker if you do want to kind of go down the path of really fine-tuning that taxonomy. So I'm going to jump into the product, and so the idea here is that Deasy Labs is a metadata platform, in its simplest form. We have a platform. We also have a set of APIs. So all of the functionality can be accessed programmatically. Now, the concept of Deasy at a very high level is that we will connect to unstructured data. So this is one caveat. So we're talking here in this conversation about unstructured content. And we can connect to either a vector database, Qdrant being our preferred vector database for us, and then we can also connect to raw files. So potentially for more like cataloging governance use cases, it might be that you want to connect to a file storage system, and then we will do kind of an OCR and chunking step. But within Deasy, you can very easily, come to data connections in here and add like a new Qdrant instance. And when you do this, you just need to provide your API key, collection name, Qdrant URL, and then importantly, you will need to have two fields within your vector DB, one which can be mapped to file name, and one which contains the actual text of the underlying chunk.
Could you perhaps like zoom in a little bit so we can see more clearly?
How is that?
Awesome.
Is that clearer? Yeah.
Yeah, that's better. Thanks.
Cool. So let me know if I need to zoom in or out at any point. So I'll go through a flow here, and what we'll do, we'll say that we're building some kind of RAG use case on a set of mostly research papers. And I say research papers here because actually, when we look at this corpus, there's a few other documents that happen to be in here that a user might not know about. And the goal of this, let's say this demonstration here, is to say, okay, I have a vector DB containing a large corpus of data. And my end goal is to set up a few different RAG use cases actually on that one corpus. So this is often another way that metadata becomes valuable is, I was talking to someone yesterday, and their problem was that they had a bunch of different teams who were all accessing the same knowledge base, but each team, in theory, only needed to look at a subset of that knowledge base. And the reality was, therefore, without having some kind of filtering, they would be looking at a ton of irrelevant data. And so the accuracy of their search was going to be, much lower because there's a lot of data that doesn't need to be there. And if you can reduce the size of that search space, you can obviously improve the retrieval performance. So for this demonstration, we'll assume that we want to basically build a few different use cases across this Qdrant vector DB. We also want to remove any data that is sensitive or redundant. And we also want to add some sort of more specific metadata to each of our chunks in our vector DB that can then either be used for, let's say, re-embedding or for routing strategies or something else. So within Deasy, the core of what we're doing, I'm just going to zoom out a little bit so the screen renders properly. So I will zoom into all of this, but the core concept is that we build out these kind of metadata sort of schemas. And this is kind of, at a high level what I was mentioning before. So we can throw in our data here. And when we add metadata, which I'll show you in a moment, you can add either, you can add your own metadata, you can auto suggest metadata, and you can do this in a very kind of layer by layer fashion. So it could be that when we throw in our data, there's some high level categorization we want to do where we want to create one tag, which is about, the file category. And just to be clear here, when we say tag, what this basically means is a task that an LLM is going to have to go through every one of these chunks of data and extract, in this case, what is the file category. And some of these tags can be open-ended, in which we don't define the output values, we don't define the categories, or they can be constrained to take a set of values. And I'm going to sort of show in the demo how we build this kind of structure, but this is how we think about, first we're going to segment by file type, and then we say, okay, within my academic documents, now I'm going to segment that into some kind of more metadata that's specific to academic content. And then potentially, within my my research domain, one of these comes back as material science. And then my material science papers, I'm going to, auto-suggest more metadata to split that out further, which then goes into kind of material type and material composition and so on. And this is kind of, this is really this human in the loop approach to both define and auto-suggest metadata to come up with like a very rich taxonomy that allows you to achieve both the segmentation sort of objective once all of this metadata is extracted, and also the enrichment objective by putting this metadata back into your vector DB alongside all of your chunks.
All right, so each one of these blocks is an LLM call, if I understand correctly.
Yeah, not exactly an LLM call, but you can, not like one call per se, but you can think of it as there is going to be an LLM that's called. So if I'll just create an example schema and I'll show you like exactly, it'll make more sense. So let's say we're starting from scratch here and I want to add a tag to all of my data, which is, let's say, something around like the objective of the research, right? So here we can manually define metadata. We can choose from a library, or we can auto suggest either flat metadata or a hierarchical metadata structure. Now, if I manually define metadata, I basically provide a name. So we can call this, let's say, objective of the research, and a description, which this then kind of acts like a prompt to an LLM. So this could be something like the specific objectives of the research. Now, what I can do is we can auto refine the descriptions either for like a classification type task or an extraction. And there is a distinction here because some of our customers, they actually want to pull out exact text. So if one of our customers in the pharma space, they have clinical trial documents and they want to know the exact inclusion-exclusion criteria word for word from every document. And so in that case, it's more of an extraction versus a classification. But when we run this improve, what we'll see is Deasy will basically suggest a refined description for this specific tag. Then I can add this to my tagging tree, and now I have this tag. And so when I run this, an LLM is going to be called, and we're going to effectively extract the objective of the research from every chunk. We will then intelligently synthesize from chunk level to file level metadata. So then across every chunk and every file, you will have a tag, which is what is the objective of the research. You can test these tags. So for example, I could come into like a tagging studio environment and I could basically test it on some example data, and I can see what kind of outputs would be generated with my current prompt, right? So I've just ran this on 2 example documents, and you'll see the file level metadata that was generated. And if you open this up, you then also see chunk by chunk, what metadata would have been generated at each chunk level. You also see the evidence for every tag that was extracted, so you can understand why did the LLM kind of choose to assign this particular value. The tags can be open-ended, but they can also be, so for example, I'm just going to add a few tags now. So some of these could be like these categorical tags. For example, my file category. Maybe I also want to there's something around sensitive data in here that I want to make sure is tagged on every file. Maybe there's something around the language. I only want to have data from like in a certain language for my use case. And so you can see that some of these tags might be, fall into buckets. Others might be open-ended. But the nice thing is what we also do is if I like open this language tag, where we've actually already extracted this, so you can see the distribution of the values across this corpus, we can auto standardize the outputs. So if I run this kind of AI suggested standardization, it will bucket all of the open-ended tags into kind of categories. So you see like Chinese and Mandarin here get mapped to Chinese. And then if I'm happy with these outputs, I can sort of confirm this. And then you see that my language tag turned into, from like an open-ended tag, into now having sort of specific categories.
If you don't mind me asking, what kind of normalization are you using there to do that standardization?
There's a few different approaches that we're doing. So we're mostly doing this kind of clustering based approach. So kind of more traditional clustering. And then we also use some LLMs depending on the type of tag.
Very cool.
So the other, so let's say now we've kind of started to build out, like, okay, once we run these tags, we're going to understand, like, what is the file, what is the objective, what type of document is it, does it have sensitive data, maybe what year is it from. But one of the most interesting things that we've already alluded to is the fact that we can then auto suggest metadata. So for example, here, once I run the file categorization tag, we'll see that, okay, most of my data comes back here as academic content. Then what we can do is say, if it comes back as academic content, we want to then run some additional tags. So here I can generate a schema that is now only going to be based on my academic content documents. So this is now running in the background. And basically what you'll see pop up momentarily is a set of tags that we believe are relevant for segmenting this academic content corpus of data even further. Okay, so these are all auto-suggested, and importantly, these are based on the documents themselves. So these aren't generic tags associated to academic content. These are tags that we believe are the best kind of way to segment this corpus of data. So, for example, the research field, publication year, author affiliation, core topics discussed, intended audience, document language, and so on. And then the idea of doing this is that you could then run these tags, and then let's say you run the core topics, and you have a particular topic, like let's say one of the topics comes back as blockchain. You can then run the auto suggest again to derive, a schema that then breaks out that part of the data further and further. And that's kind of what I was showing on the, on this demo tree that was that I just ran beforehand. We ran a tag which was primary research focus, and we see that, okay, one of the areas that came back was material science. And then when I deep dive and auto suggest a tagging structure further, it then says, okay, material type breaks out into these three categories, and then material composition breaks down further, and so on. And this is this kind of hierarchical structure can also be fully auto suggested by Deasy as well. So this is really the process of building that schema that best represents your data. And then once you have the schema, you can run the extraction process on this extract panel on the bottom right. And as I mentioned, this is then we're going to use a series of models to extract both chunk and file level metadata. If I go to view metadata, I'll show you here some of the example outputs once this has been extracted. So let's just add a few things in here. So here what I'm doing is I'm just adding in the metadata that's now been extracted.
I'm now thinking about the scalability of it, Reece. Like, if I have, for example, 1 million documents, how heavy will it be for me to generate all this metadata?
Exactly. So this has been one of our core focus areas over the last few years, just given the nature of the companies we work with and how much data they have. This has to be, from both the time and compute cost perspective, scalable. So first thing to say is this is a very big focus area for us. I mean, the metric I can share is that for around 10,000 files, each around 75, 80 pages long, extracting kind of 10 tags from every page. So 10 tags for, let's say, 80 pages of every document times 10,000 will take around 25 minutes right now. So generally the solution is super scalable. The tagging, it doesn't have to be in real time. I think that's also the nice thing with, if you're using this in retrieval system, the upfront work is to create the metadata. And then once the metadata is created, it's kind of this incremental, maybe there's new data coming into the system every day, a few thousand documents that get tagged on the fly. But then once the metadata is there, you can obviously use it. You don't have to create anything in real time. And we optimize in the background also choice of, we have a bunch of different models that we're using, and we will optimize kind of choice of model depending on the task as well. Ultimately, as a company, what we try and strive for is the maximum tagging accuracy to cost ratio for whatever it is that we're extracting.
Yeah, absolutely. And for example, if once, of course, everything is already tagged in within my database, the work would be much lower. But how would Deasy work with like documents getting added or updated within my database? Like, do I put them through Deasy first? How would that process kind of look like?
So what's nice is like often we will set up kind of a tagging taxonomy, or the user will set up a tagging taxonomy within Deasy, potentially using the UI because it's much easier. And then at any point they can just call that. They can call that via an API. So as new data comes in, they can basically call an API to run a particular tagging structure across the data, and then the metadata will be extracted accordingly. And why that's nice is because of the way we segment layer by layer, you can throw it doesn't really matter what the data is that's coming in if your tree has been set up correctly, because it could be a document comes in, we first assess what kind of document is this, and then that determines what subsequent tags are going to be extracted. So that's kind of how it would work. In some other like enterprise settings where they have like a SharePoint folder, what we can also help build is a way to effectively scan for new data that is added, and then we can update. We can basically automatically trigger that same sort of tagging API as new data is going into the system.
Awesome. Could you again like do the zoom?
Yes, I will. I'll zoom in 1 second. Just to show you kind of conceptually what we're looking at here. So
Okay.
metadata has been extracted. What you see on the left, these are all the files. On the right, you see the different, on the top, you see some of the tags that have been extracted. And then you see the values for this document here. So, I mean, the first tag here is, key questions. So what are the questions that this document can answer? And you see all of the questions for this document that have been, summarized as file level metadata. But if I click into one of these, you then see the breakdown by chunk, right? So you see the chunks here, and you see the chunk level metadata below it as well. So we're generating metadata both at the file level and the chunk level. And all of the metadata we generate, we also have the evidence here. So you can always open these up and see like where did this come from? Why did it tell me this was the metadata value? So this is kind of how to think about viewing the outputs, and immediately you could just export this as a structured data set. But the next concept, coming back to like the overall problem statement here, which is I have a one vector DB, but maybe I want different RAG use cases or different search use cases, not necessarily RAG, across that vector database. And this could be, for example, different user groups who access different types of data. It could be that you actually just have like a lot of data in one vector DB that is very heterogeneous. And maybe some people want to work on policy documents, another team want to work on research papers, but it all happens to be there because it was all in the same, SharePoint, repository, whatever it might be. So this is where we have this concept of data slices. And a data slice for us is a way to create a set of conditions based on metadata that determines what subset of my vector database is going to be exposed to my end user group. Okay, so if we create a data slice in Deasy, we can, let me add back in some of the tags we've created. And then I can show you, how we might potentially think about filtering on them. So let's say maybe year of publication. Okay, so let's say now we've created this metadata, and I'm going to assume randomly. Let's say there is a team who want to build a retrieval use case just on data in the material science domain from the last 5 years. They don't want sensitive data in there. They only want academic content. So what you can do is basically create a data slice in Deasy that, in line with those conditions. So we can say here, okay, primary research focus, we want to filter just for data that is about material science. We want our sensitivity to be no, so there's no, sensitive data. We only want academic content. We don't want kind of other sort of reports from online sources and so on. In terms of language, maybe we also want to specify we only want data in a certain language. We potentially say here, year of publication, we only want data that was from 2021 and later. Okay, so I now define the conditions for a specific subset of my data, and then I can create a data slice. So I could call this material science, let's call it research, if I can spell. There we go. And then this is basically now defined as a new data slice in Deasy. So how that gets used in practice, if I create this data slice, this then exists here. And how that gets used in practice is that if I'm now building a retrieval system, you can call our data slice API, and you can pass the name of the particular data slice that you want for a particular user group. We will return basically like the metadata conditions for filtering your knowledge base in line with that particular data slice. And then when queries are asked, then you'll only look at the relevant subset of your vector database. How that is orchestrated depends on, are you using like a llama index, a LangChain, and the different ways that these tools can be work with metadata to kind of filter. But that's really the concept here. The last thing I'll just share, and then I'll pause because I know we've got about 15-20 minutes for any questions, is once I have my data slice, how do I then get this metadata back into my vector DB to work with for improving my search? So here I can open up my data slice. I can see kind of how many chunks are in here, how many tags, and so on. And I can choose what metadata. Now, this is where kind of the enrichment side comes in, because I segmented my data based on things like publication year and language and domain focus. But now I also have all of this other metadata that's been created that potentially is very helpful for my search. So I can start deciding, okay, what of this metadata, like what else do I want to add back into my vector database? And this can either be you define this manually, or we can also auto recommend what metadata you should use to enrich for your use case. And you can see on the right-hand side kind of the volume of tags that have been created at the chunk level and the file level. You can preview the metadata, and then we can export it directly back into Qdrant. And the nice thing here is we can check the sync status. So we can basically see what metadata already exists within Qdrant, what metadata exists within Deasy's sort of metadata database. So you can kind of sync up, okay, this tag now is only actually been applied to 80% of my chunks. I need to resync it, and basically I want now my metadata to come in on my remaining chunks. You can also choose, am I pushing file level metadata or both file and chunk, or just chunk to my chunks? And why this is important is like a typical example. Let's say we're looking at policy documents, and every chunk of those policies, you lose the context of the document when you just look at the chunk in isolation. But if we have the file level, let's say date of the policy, then we can add that to the chunk so that when you look at a chunk, you then have a lot of file level context, which will improve the retrieval performance. And if I go to Qdrant, just to show you what this might look like. So here I have here I have a chunk of data, and then next to it, I have all of these tags that have now been created and pushed back into Qdrant. Some of these were yes, no tags. Some of these were categorical. Some of these were like the key questions, so more descriptive. And once this metadata exists in your vector DB, there's many ways to work with it. So yeah, I know that we covered a lot of ground there. So yeah, happy to kind of go through anything again or answer broader questions. But that's kind of that's the focus. And I do have one question also, Serena. We have today we're basically providing making sort of access to Deasy as a SaaS platform available. So we have a link that we can share. I know my team are on the line. I'm not sure the best way for us to share that, but that's a question. Otherwise, we can later today in a few hours' time, if you go to deasylabs.com, it'll be possible to basically start accessing like a SaaS version of the product. But yeah, let me stop there.
If you have the link, you can share here in the studio. I think post a comment. We'll go to all the places that are streaming. Right now we have almost 100 people watching, so that's pretty cool. And then we can post on the link in the description of the video for the recording version.
Perfect. Okay, I will do that in 1 second.
I'll definitely be testing that for some use cases I already have in mind. One in particular is really searching Qdrant docs. So I think that would be very interesting because there are a lot of things where I can see this being useful.
Yep.
For example, hybrid search alone, it's great, but it still like misses a few things that I saw Deasy bringing up perfectly. And I also wonder, like we talked about like turning this into hybrid search, and how would we go about like turning this into sparse vectors and also inserting into the database? Can we do that directly with Deasy in a way?
So yeah, we don't, and this has been a point of constant back and forth for us as a company. And one of our realizations over the last year was that every team builds their retrieval differently, and they have a different approach. And so we actually at one point we had a retrieval API, and we helped set up those vectors for our users. But now we effectively draw the line at we are the the metadata orchestration layer. So people should think about Deasy as like kind of in the context of Qdrant, like a managed metadata service for your vector DB, and then how that metadata is used for creating vectors or for routing and so on is really up to that team. Sometimes when we work with larger companies, we'll spend some time doing some workshops and sharing our learnings on that based on what they're trying to do. But yeah, really our focus is how do you come up with the right metadata, how do you extract it in a scalable way, how do you test and validate, and how do you keep it up to date as new data is coming in.
Very cool.
I've just sent a link. Hopefully, does that link go to? I've sent it, and maybe that just goes to you guys.
Yeah, this one goes for us. You need to send it on comments. And also, everybody, if you guys have any questions, please drop it in the chat. And Reece will answer them, or us will answer them. There's also like a lot of touch points around the scalability within Qdrant itself, right? The indexing. And just a quick reminder to always index your payloads. And I think for this level of metadata, you would need to do something like on disk payload indexing to not overload your RAM, right?
Yeah, and maybe one point on this is also like we also learned like too much metadata also can be quite damaging as well. So this is why like at that last step we now think a lot about how do we recommend like the right tags to add, because adding all the metadata can, if you don't have the right metadata, it can make things worse. Same way with embedding the metadata and how you route and filter. Sometimes metadata filters can be can be more damaging than good if they're not set up in the right way. That's why we emphasize so much on like the quality and relevance of the metadata.
Yeah, and Miko just dropped the link for app.deasylabs.com and head over there if you want to sign up. This is so cool. I'm already thinking about projects that I want to build because two things came to mind. The first is actually, I think that this ties into role-based access control, which is a demo that I just worked on for Qdrant. And I think it'd be interesting to use DZ in addition with role-based access control to figure out what your roles should be, or kind of how to separate your data or how to create tags that make sense for that enterprise setting. And then the second one is I have a friend who works as a women's health lead in the Bureau of Health for the Texas government. And she has asked me, hey, how hard would it be to create an app that looks at all the bills that are introduced in the Texas legislature and give me some kind of AI analysis on how we should respond to this bill? Because one of her mandates is if a bill's released that affects healthcare, you need to respond to it, say whether you support it or don't. And currently, there's humans that are manually looking at the bills, and some days they might introduce like 77 bills. And that's just someone has to read through all of them. So tasks like that, I think, would be super interesting to use Deasy on, because a bill, kind of like, how do you break a bill down into a summarization, right? Outside of just taking the paragraphs of the bill and making them sentences. Well, something like Deasy, I think, would be perfect for that.
Yeah, no, thank you. Yeah, I think that any kind of we saw, I guess, three or four buckets of use cases. One of which is like this broad cataloging and how do you represent data in a different way. And sometimes for us, even as a team, it's interesting just to throw in like our entire like file repository and just see like how would an AI think about structuring all of my information, which can be quite insightful as well. Figure out what's actually in there. Yeah.
Also, something that came to mind is I remember one question once we got on Discord that was this person that had this data set of T-shirts or like clothes, and only some of them had metadata. And he was trying to figure it out. Okay, I want to rank those who have metadata on top of those who don't have, because those I know they are correct. For example, white t-shirt, if someone searches for white t-shirt or something. And I wonder if Deasy also works in that way for like maybe multimodal files. And we also have a question here from Nilesh asking, does Deasy Labs support metadata for code files / code repos, like code hierarchy of metadata?
Yeah, great question. So I think there's actually also a subtle point in what you mentioned, Serena, also around sometimes some metadata might exist and some metadata might not exist. And I think that speaks to a broader question of like when we work with companies, often there is already some metadata. And that could be metadata that exists in their system, or they already have some taxonomy, or they already have some business glossary definitions. And so a lot of what we also think about is we don't want to reinvent the wheel. We don't want to make them define everything from scratch. So how do we allow people to import like existing taxonomies, existing tags, and then we can kind of fill in the gaps. So that's also like an area that we think about with regard to kind of the modality. So we do support right now. We support kind of if we have like images and charts and tables that are in documents, we're right now bringing in the capability to basically describe them and then use the sort of text output to generate metadata on them. But in terms of file types, so like PDFs, Word docs, text files, things like CSVs and databases, if it's like a CSV, if it can be converted to a markdown, we can then create metadata describing like the contents of the CSV, but it wouldn't be like row by row. So that's how we think about it. We right now, so Miko's responded there. So we can create metadata from code files, although the direct integration isn't there.
I've got a question here, if you don't mind me jumping in. What are you most excited about in AI right now?
That's a very good question. I mean, I think we've gone through this period where there's been, so much noise, right, around, especially thinking, obviously I'm biased, we come at this from like the software perspective and different applications that exist. And I think we're getting to a point where the rubber meets the road in terms of what actually creates value and what is just like hype and what is excitement. And I think one way we saw this reflected was like in large companies, like the willingness to do kind of POCs and test things was very high, but seeing the volume of those things that actually make it through is very low. And we also know this ourselves. We experiment with AI tools all the time as a team, from in the marketing, sales, code optimization. And I think what gets me excited is when you stumble across like one of those tools that actually is like, wow, this is actually going to change something for me. Because I would say there's a very long tail right now of things that seem cool on the surface, but when you start using them, when you start applying them, there are big gaps. So I think for me, we're getting to a point where maybe more of that noise is hopefully going to start getting sort of filtered out. I don't know, maybe it'll get worse, but finding more of those tools that can be applied either to our lives or to our customers' lives that are genuinely going to move the needle on core topics, I think is something that's very cool.
Yeah, and I think you mentioned earlier kind of that if you have 80% accuracy, it might as well be 0. And I think LLMs are such a fascinating problem, because if Amazon takes an extra day to get you your package, you're still going to use your package. You're still going to use Amazon. But for the LLM, if you don't get the right answer even once, especially in an enterprise setting, that might be enough for you to just swear it off forever and never come back. So it's really important that people are getting that last mile done, because it's kind of the first mile as well.
Yeah, it's we see it a lot with the problem is I think data and data science teams have to basically get the business on board, right, to move ahead with these things. And we work a lot of teams who are fighting their own internal battle because they shipped something too quickly. A bunch of people tested it and immediately decided that it wasn't like up to their bar. And I think this is also the problem with, like, we talk about co-pilots, but I think in many cases the assumption is like it's not a co-pilot, it should just be doing kind of everything. And I think it's really important to remind people, even with what we do, like we can generate taxonomy, but actually like the best version of this product is going to be when you have kind of some human input, some auto suggestion, and you work with it. And I think that's true in a lot of cases. And anchoring people on that reality, I think, is important to manage expectations as well.
Yeah, I think we're starting to reach that point, kind of like you said, where the chaff is going to get separated from the wheat, and you really need to be delivering value, because otherwise you're just going to get left in the dust. Like you mentioned, everyone's happy to do a POC for some kind of internal tool, maybe even an external tool, but getting from POC to prod is really where the value is.
Yeah.
And I'm also thinking, Reece, about maybe best practices that you've come to know, obviously, like when creating metadata, or maybe things to avoid when creating metadata. If I'm not using a platform like Deasy, still, what should I keep in mind that would what should I stay away from that would degrade my search? And what should I think of having when I'm creating my metadata and updating it?
Yeah, it's a great question. I mean, I think one of the core, unsurprisingly, I think one of the core pieces here is like figuring out, like ideally, like a centralized taxonomy, and then everyone works out from that. I think what happens in so many companies is like everyone defines their own metadata, which maybe works for like one project, but as soon as you start to bring in data from different domains, different sources, it becomes basically impossible to manage, because everyone has been defining things differently, different taxonomies. So I think the first thing I would say is like, think about, from a data perspective, how do we start to build like a centralized taxonomy? And this is why, to be honest, I think most companies' metadata is a mess, but with GenAI, there is kind of this new lens to metadata, which is around, okay, with regard to my vector databases, with my RAG use cases, with my GenAI use cases, there is an opportunity to kind of start fresh in some ways from, what is going to be my taxonomy for, and my metadata approach specifically for kind of unstructured data within GenAI. There's something around standardization. So I think if you're using metadata as filters, this becomes very problematic. As I said, like, it can be more damaging than good if the categories aren't filtered correctly. Maybe it's countries or something basic, but you have 3 variants of USA, and actually you don't realize that you're filtering out. You want to filter just on data about the USA, but you actually filter out every time like 70% of the candidate chunks because metadata wasn't standardized. The synthesis between chunk and file level is also very key, because if we're talking about something like publication date of a research paper, the problem is that like probably many pages of the research paper, if it's chunk by page, have some kind of date on them. And you need a way to know like which one of these actually at the file level, what's actually the publication date versus what was like a date of some other thing that was referenced. And that's quite a hard problem, and one that we spend a lot of time on thinking like, this is why the evidence is so important. Like, how do you, when you're synthesizing, it's not just a tag value, but it's like almost the weight and the importance and the evidence of that tag when you're synthesizing from like a chunk to a file. And then I think the last piece is building these taxonomies so that they are dynamic. We could auto suggest a taxonomy today that says, here are your 5 research topics. Okay. But the problem is that like that data will be changing over time. And we don't want to, if the data changes, we don't want to always constrain it to take one of those 5 values. And we didn't show this in the demo, but one of the things we do is we basically say, okay, a new bucket has been suggested based on the data. So we can say, okay, Thierry, to take the animal example, you had like these 10 types of animals, and then you get some more data in, and instead of pushing everything into cats, we actually say, there is a new dog bucket that you should consider. So having that ability to redistribute and create new categories as data changes is also a key piece. I can talk a lot on this. There's a lot of stuff on like choosing the right model, not overdoing it on like the compute side. You can use few-shot learning to use a more complex model to create good sort of training examples, and then maybe run the classification using a smaller model to optimize the kind of the cost to accuracy ratio as well. So there's different things there.
And
That's amazing.
Just quickly, mind speaking to your experience with Qdrant, any tips or tricks that you would recommend for people out there? What about it do you like?
Yeah, well, I can. My 2 of my co-founders spend all day, every day in Qdrant, so they can probably share a few things in the chat that that will kind of be quite insightful. But we've tested every vector DB, to be honest, and we always recommend our customers, if they're open to trying new vector DBs, like we just prefer working with Qdrant from a scalability perspective, ease of use as well. So generally, I think it's always been our our vector database of choice. So yeah. And I think also I just saw a question from...
Yeah, there is a question from Julian. Thank you for the great presentation. How easy it is for a user to generate this metadata and make sure they use it properly? Do they require some level of support to ensure proper usage?
Yeah, I mean, probably, at a high level, we want to make it as easy as possible. That's been our goal, that with the auto suggestion and so on, so that people can basically come up with the right metadata themselves. Of course, like any tool, there's a bit of a ramp up to understand how the product works. For example, like every time you auto suggest a taxonomy, it's going to be slightly different because we're leveraging LLMs in that process as well. So like understanding the sort of there is a learning curve there as well. And again, in terms of like how you use the metadata, this is something we're always happy to chat about with people using the product. Like only yesterday we had a chat with a team who have used Deasy, a research institution. They've created a lot of metadata, and now they're considering like what approaches should we take to actually get the most out of this. And so that is kind of, those are learnings that we're happy to share with teams as well, if people already don't know. And I'd say there's almost two buckets of people we work with: those who know they know how they want to use metadata, and their issue is like, how do we create metadata and how do we get the right metadata? And then other teams who want to improve search performance, and we kind of educate them a bit on the role of metadata in that process.
Awesome. That's super cool.
I don't know about you, Thari, but I'm ready to go and start using Deasy.
I'm ready to cook up some metadata. Yeah, no. These webinars are always so much fun because you get to learn about new technology, and it's like, yeah, there's a million different startup ideas that Deasy is creating with this product. So hopefully some of the people in the crowd will be some of those people using it. And we have someone coming in to say, amazing presentation. Once again, thank you for everyone joining us. This was awesome. I just want to quickly say, what is the Deasy logo, if you don't mind me asking? Is that a shrimp, a mantis perhaps?
I'm glad you recognize it as shrimp. That's exactly what it is. Yeah.
Okay.
We were in, I don't know why, we always had this like affinity for having some kind of logo that was an animal, and we thought no one's ever disliked a shrimp. The problem was the first version of the logo looked very much like a seafood restaurant. So over the years, it's morphed into more of a Microsoft style shrimp. And Deasy itself came from, it was always around like making data easy. So that was where the sort of the name Deasy also originated
Okay,
from.
making data easy. Okay, very cool. Very cool.
I love that. Just a reminder again to try Deasy Labs. Go to the app.deasylabs.com. And thank you so much, Reece, for being here with us. Amazing presentation, and really excited for trying this out.
Thanks, guys. No, it's been great to chat with you, and thank you for everyone that's joined. Looking forward to hopefully getting to know more people.
Absolutely. Thank you so much, everybody.
Thank you.
Bye. Bye.